Your voice is muted, Abdullah. Voice is muted.
Good morning, ladies and gentlemen. Today, our conference will be a biograph about our presenter today, Mr. Kasi. Good morning, Mr. Kasi. So, we will be having a brief introduction about Mr. Kasi's biography. So, Mr. Kasi is a senior lecturer in Mass University. He joined Mass University in 2005 as a senior lecturer in the Faculty of Engineering. He has a total teaching experience in universities and engineering colleagues in India, and he has a total experience in teaching in Malaysia for 20 years. He did his bachelor's degree in the year of 1999 and one in the 2005 at the Government College of Engineering. He attended a number of faculty development programs, workshops, training in his area of specialization. He organized a number of national level conferences and national level seminars. He published around 12 international journal papers and attended 20 international and national level conferences. This is in India and Malaysia as well. His research areas are solar power plant, electrical vehicle, microbial fuel cells, and power electronics and drives. Currently, he is working with the Eco Village team in Massa University. He received the Massa Research Grant for research project, which is about enhanced hydrogen production for electricity generation using effective microbial consortia from vegetable wastes. During April 2021, he received a patent A robotic system to check battery quality in manufacturing industries using artificial intelligence on 27th of April 2021.
Okay. Thank you, Abdullah.
Thank you, Doctor.
Good morning, all. I'm sharing my slides. Yeah, today's topic is electric vehicle charging techniques. Nowadays, we are facing a lot of problems with the existing fossil fuel uh, vehicle, vehicles. So there is an alternate we need. So that one is the electric vehicle. The fossil fuels polluting the nature and our environment. So due to that pollution, the global warming increases. So we need to reduce the global warming. Also, the fossil fuels nature is diminishing after certain years. So we have to go for renewable energy sources. One among them is solar, then wind power generations, and tidal. So these are some renewable energy sources. Okay, so electric vehicle charging, this one main objective of today's webinar is to create awareness about the electric vehicles and go green energy. And outline of the today's webinar. So how the progression from bullock cart to electric vehicle. See, in olden days, our grandfathers, grandfathers using bullock carts, and how it is step by step how we improve in the transport from bullock cart to electric vehicle, battery operated electric vehicles. Then what are different types of vehicles we are using, then what is electric vehicle, what are the main components of electric vehicles, then types of charging, and what is wired charging, why we should go for solar charging, then what is wireless charging, and what is the importance of wireless charging, some projects related with the wireless charging, then MATLAB wireless charging I developed, then conclusion and future direction. And olden days we are using the animal cards, bullock cart, horse cart, camel cart, elephant cart. Then we slowly move to the bicycles, tricycle, auto rickshaws, then diesel cars, petrol cars, hybrid cars. Then nowadays we are using electric, battery operated electric vehicles. Then how in future how the electric vehicles can be nowadays we are facing the problems of fossil fuels. uh, Around 2045 the electric vehicles as well as hydrogen based vehicles will coming up, and around 2070 the entire all the vehicles will be replaced by the electric vehicles. There is no more fossil fuel based vehicles. Okay. So types of vehicles. Nowadays we are using petrol and diesel vehicles. They pollute the nature, and due to the pollution, the global warming increases. Then hybrid vehicles. Hybrid vehicles means combination of gasoline engines and battery operated. So, but there is no charging port in hybrid vehicles. But in electric vehicles, for example, fuel cell vehicles available, battery operated vehicles. In the battery operated vehicles, we are having the electric motors. So the electric motors get the power from the batteries, and the motors rotate the wheels, and so the batteries can be charged by the charging stations. So different charging stations nowadays developing and developed. For example, solar based charging stations mainly we can focus in future, and nowadays also they are developing. Why we should go for electric vehicles? Since it is pollution free and less carbon emission only, it prevents global warming from some extent, and scarcity of oil after 40 years. So after 40 years, we don't know the availability of the fossil fuels oils. So that is definitely a scaring one. And EV is clean and secure, less noise only, less noise pollution. But why EV is not coming up previously? Since it takes a long charging time for the batteries, and moreover the batteries are very bulky and heavy, and then more expensive compared to IC engines. operating and maintenance costs were high compared to IC engines. Not enough proof for its safety. And around the 1990s, lead acid batteries were used, and it is so heavy and bulky. So, due to these reasons, the EVs are not coming up previously. Now we are focusing mostly on electric vehicles, and in this electric vehicle, there are different components. Electric motor, different kind of electric motors we can use for electric vehicle. For example, brushless DC motor. So there is no brushes in the BLDC motors, and with the help of the batteries we can operate the brushless DC motor. Then motor drives. So motor drives are used to drive the motors, like brushless DC motor, permanent magnet synchronous motor. So these are mainly used electric vehicles, and moreover induction motor also we can use, but induction motor requires the AC supply, and the motors can be driven by the motor drive circuits and power converters. Mainly power converters, if you see, we are using rectifiers and inverters for power conversion. For example, AC to DC will be converted by the rectifier circuit, and inverter circuit converts the DC to AC. Since the induction motor requires the AC, so the inverter requires the DC supply to AC, so that we can drive the induction motors. Then battery banks. So battery banks, traction battery packs are available for powering the electric motors, and for auxiliary devices, auxiliary battery bank also available. Then onboard charger. So charging, we have onboard charging as well as off-board charging. Onboard charging, the charging circuit is available in the car itself, but off-board charging means the charging circuit not available in the car, the charging circuit available in the charging station itself. Okay, so then charging plugs are available to charge the batteries through the charging circuits. And these are different battery models available. Then types of charging. We have wired charging. Nowadays we are using wired charging for our mobile phones, electric appliances. Then electric vehicles, we are using the wired charging. But wireless charging slowly developing. Wireless charging, static wireless charging available, and dynamic wireless charging also available. In the static wireless charging, the cars or vehicles can be moved to the charging station, and we need to place the car over the charging arrangement. Okay, in the ground, we have the energizing coil. So from the energizing coil to coil which is placed in the cars gets the energy. Okay, these cars having the another coil, another set of coils. So from the energizing coil to, that is transmitting coil to receiving coil. Receiving coil is placed in the electric vehicles. So we can transfer the energy from the energizing coil to the receiving coil. So the energizing coil is connected with the power source. The power source can be our electrical, our home also, home, or separate charging stations like solar charging stations we can have. So from the charging stations we can transmit the power through the energizing coil to the receiving coil. Receiving coil is placed in the electric vehicle. So this is static charging, and dynamic charging also nowadays coming up. In the dynamic charging, actually, in the road, the energizing small energizing coils will be embedded in the roads. Through the coils, the car vehicles will move. So while moving itself, it gets the charge from the energizing coil. since already the vehicle is having the receiving coil. So the energizing coil placed in the roads will transmit power when the electrical vehicles are moving nearby. So the sensors will be sense the availability of the electric vehicles, and after it goes return to some go to some distance, this energizing coil will be turned off. So this is the dynamic charging. Researchers are more concerned about this one, and but it will nowadays it is very expensive. But in future, we'll develop this kind of dynamic charging. Then advantages of wired charging: reduce infrastructure cost. The infrastructure cost is less. Then high power transfer efficiency due to the wire, high power transfer efficiency. Then possibility of high speed charging, but increase in costs. Then low maintenance requirement only for wire charging. Virtually no electromagnetic emission. See, these are some advantages of wired charging. That's why we are using that one. But some disadvantages also available. It need human intervention for connection. Not having an automated process, so automation is not possible. But in case of wireless charging, automation is possible. Without human, automatically we can get the power in the dynamic charging, isn't it? Then the cable takes up space in the parking area. So these are some disadvantages of wired charging. uh, Throughout the world, we are using different kind of wired charging. Like in our homes, we can charge the vehicles. Then in the office also we can charge the vehicles. Then fast charging also available. Okay, so these are different charging. So they categorize depends upon the charging methods. One is mode one charging. Here, some charging does not provide users with shock protection. We don't have the shock protection against the DC currents. But in mode 2 charging, we have the electric shock protection. Built-in protection is available. And most common, we are using this mode 2 charging. Then mode 3 charging, here the connecting cable provided with the wall box or charging station, and EV does not need a dedicated cable for charging. Currently preferred means of charging electric vehicles is mode 3 charging. Then mode 4 charging, widely varying charging rates for mode 4, and currently 5 kilowatts through 50 kilowatts we are using, and 150 kilowatt plus soon will be rolled out to 350 and 400 kilowatt standards. So in electric vehicle onboard chargers and charging stations, there is level 1 and level 2 charging stations. Here, AC charging system power flows from the grid to the battery pack through the AC to DC converter. So AC to DC converter means, as I mentioned earlier, it is a rectifier circuit. So rectifier circuits are available in the electric vehicle. So this get the AC power from the grid and converts it into DC. Okay, so high voltage DC is charging your battery pack. This is available in level 1 and 2 charging. But in level 3 charging, we have EVSC, that is AC to DC converters in stack of manner, so that we can reduce the increase the efficiency by reducing losses. So from grid to battery pack, it is charging the power. So that is level 3 charging. And charging stations we have depends upon the number of hours charging. 17 hours takes charge for AC charging station. This is level 1 residential charging, and level 2 commercial charging in AC charging stations. That is, it will take approximately 8 hours to charge. Nowadays, supercharger are also available. That is level 3 DC charging station. It takes only 30 minutes. Can you imagine? Only 30 minutes to charge the batteries. Within 30 minutes. So the charger power requirement is 120 kilowatt to 240 kilowatt. So if we have this kind of charging station, then within 30 minutes we can charge our batteries. And worldwide, different type of connectors used. AC charger sockets, that is in Japan and USA, Esaki sockets they are using, and Europe, Germany, Menakes sockets, and France and Italy, Legrand sockets. These are AC charging sockets, and DC chargers in uh, Nissan Leaf kit, Mitsubishi. In this Chatno type of chargers are charging sockets are available. Then Mahindra Chinese EV GBOT type of chargers, and Tesla supercharger is used on Tesla S and Tesla 3 type of vehicles. Okay, these are different type of charging connectors. Then why we should go for solar power charging stations to charge the electric vehicles? Here, putting the power point using electricity from the grid. So from the grid, we can get the electricity to charge the batteries. Solar panel generates the DC power, but grid is consists of AC. So we need to convert DC to AC with the help of photovoltaic PV inverters. So PV inverters are available. Different kind of PV inverters available. We can convert DC to AC with the help of PV inverters and export the power to the grid. So from the grid, we can charge the onboard, that is our electric vehicles with the help of the charging stations. So the solar means it is definitely a green energy. So we are not using any fossil fuels. So it will not pollute the environment, and so that's why we are going for solar. And the existing ones are expensive and takes long time to charge. So recharging at public charging stations, what is the demerit means? Is more expensive and too many different payment systems and not practical, not enough charging stations. So these are the reasons why we are going for solar charging stations. um, Charging at home with solar power system, so that one 100% renewable power and independent from power companies. So we don't need to depend upon any companies. It is fully independent and affordable with grid and uh, grid prices. Then why should we should go for solar charging station to charge? Solar panels we can put in different orientation and inclination, and wall boxes are available. It is intelligent charging device. It only communicate with the particular system only. So that's why it is we are saying this as intelligent device, and make sure only charging with solar power only. So that intelligence is having. And what are the components needed for the solar charging station? EV charger, electric vehicle charger, solar panel array, then installed on roof and ground, battery energy storage system, then solid foundation. Then only it can withstand the heavy rain or heavy wind like natural disasters. It can withstand. Then intelligent software, the software is available, then it can understand whether we are getting the power only from the solar or not. Other means it will not permit to charge. So that kind of intelligence is available. And this is the setup for solar based electric vehicle charging station. So solar array gets the electricity, gets the power from sun and converts it into DC, and DC is given to inverter through the control system. So the control system charging the battery bank, so that whether the battery is fully charged or not. So those things will be available in the control system. If the battery is fully charged, then it need to cut off the connection to the battery, and if it goes below certain level, then it needs to charge the battery. So those informations will be available in the control system. Simultaneously, we can convert the DC to AC with the help of the inverter, and inverter output is AC, that is given to the charging stations EV. That is so through that one we can plug the power from that arrangement to our electric vehicle. Then wireless charging. See, whether the wireless charging rules the future world or not. Yes, definitely. Since dynamic charging, in the dynamic charging, no, not much investment. Only we need to embed the coils in the roadside only. So initial cost only. After that, there is no high cost is required for further improvement or anything. Only maintenance cost, that also less only. And so due to the dynamic charging, we can reduce the costs much. So in future, definitely move to the dynamic charging. Then history of wireless charging. Nikola, a scientist, he invented this technique 100 years back. So he made a 187 feet tall tower to broadcast energy. He managed to light 200 lamps from a 40-kilometer distance, but due to the shortage of funding, that project was stopped. After 100 years, MIT students again doing the continuing the project. The project name is City. Then examples of energy transfer in near fields and far fields. With the electromagnetic induction and electromagnetic radiation, we can transfer the power within short distance or far away distance. And we only focus on near field, that is magnetic field and electric field. Magnetic field, due to electromagnetic induction, magnetic field is done, and electrostatic induction, electric field. Then electromagnetic dynamic induction, we have inductive coupling and magnetic resonant induction. So we know the resonance condition, isn't it? So at resonant condition, the XL equal to XC. Inductive reactance should be equal to the capacitive reactance. At that time, maximum power we can transfer from the primary coil to the secondary coil. So based on that principle, the magnetic resonant induction is used. Inductive coupling, like our transformer principle, from the primary coil to the secondary coil, we can the flux is transmitted, and secondary side load can be connected, and load get the power from the inductive coil, inductive coupling arrangement. Then wireless power transmission. Here, power ratings and range of transmission can be transferred to an electric field, magnetic field, and electromagnetic waves. So it depends upon the distance. WPT, wireless power transfer, can be near field and far field, as I said earlier. And where we can apply the wireless power transfer. So due to its advantages, we can use to charge the mobile devices, electric vehicles, then home appliances. Even in satellites also we can use solar power satellites. Then defense system also we can use the transmitting the power from one area to another area. So here we have closely coupled inductive charging and loosely coupled inductive charging. In the closely coupled inductive charging, maximum power we can transfer from the primary coil to the secondary coil. So here AC. So by changing the frequency, we can change more power to the secondary side. And in the secondary side, we have the batteries. The battery source requires only DC. So we need to convert AC to DC with the help of the rectifier circuits. So loosely coupled, so quite far away, the secondary circuit from the primary circuit. Here some energy can be lost due to the distance. But here also we can charge the batteries. So with the help of compensation network and AC to DC rectifier circuits. Inductive power transfer system. Here, the input power supply frequency is 50 hertz only, and we have the high frequency converter. So the frequency can be increased with the help of this one. Then secondary side EMF induced due to AC flux, alternating flux, and primary and secondary coils are loosely coupled since separated by air gap. No core is used here. So main AC source having 50 hertz. So AC can be converted to DC with the help of rectifier in the primary side, and that DC is converted to high frequency AC with the help of the inverter. That inverter converts DC to high frequency AC by controlling the switching of the devices, power electronic switches like SCR, MOSFET, IGBT, so power BJT. These are power electronic switches. By properly turning on and turning off these switches, we can change the frequency. So high frequency we need, so the turning on and off of the switches is more, so that we can increase the frequency. That increased frequency AC is flow through the primary coil. So from primary to secondary, it is transmitted with high frequency. Okay, so in the secondary side we have rectifier. So rectifier converts AC to DC since the battery requires only DC power. So battery gets the energy from the rectifier output, that is DC. Okay, that way we can charge the battery circuits. And this one is the same. How the switches are connected in the inverter, and CP and LP primary side, and CSLS capacitor and inductor in the secondary side. And we have the secondary side diode rectifier, so that convert AC to DC, and CF is the filter capacitor for reducing the ripple content which is present in the output of the DC rectifiers. And the filtered out DC, that is pure DC, is given to your load. Here R0 is the equivalent resistance of your our battery only, battery. So V0 is the output which is used to charge the battery circuits. And this is the equivalent circuit of the previous one. And here the IP is the primary current, but the source minus j omega ls, sorry, is the secondary current. So this is mutually induced current, that is from the secondary side to primary side. So is in the primary winding due to the mutually induced. So similarly, minus j omega m ip. So ip is the primary current, but due to the current or flux linking the secondary side coil, due to that mutually induced. Okay, so mutually induced current is ip, and cs is the secondary side capacitor, ls secondary side inductor, and rl is the load resistance, that is equivalent resistance of a battery. CP primary capacitor, and LP is primary inductor. VP is the primary voltage source, AC voltage source. And how to design the wireless power transfer circuit. So primary voltage VP equal to ZP, impedance time. So these are the design by selecting proper components, proper values for the components, that is inductance, capacitance value, so that resonance frequency omega naught, we can transfer more power from the primary to secondary circuit. So these are design details. So at resonance frequency, that is pure resistance, pure resistive circuit. So XL equal to XC. So based on that concept, we can calculate different parameters using this design data. Then These are some projects. There is speed of EV can be very high. So this is one kind of dynamic charging, dynamic wireless charging. So as I said earlier, the coils can be embedded in the road. So through that coils, the electric vehicle can move. Whether the electric vehicle coming in the same lane or move from the adjacent lane, so that will be fine from the by the energizing coils, so that based on the it charges the electric vehicle. Okay, so here three-phase supply, power factor correction PFC circuit and corrected the power factor and gives the power to rectifier circuit. So rectifier circuit, AC is converted to DC, and the DC is given to the H bridge. So from the H bridge converters, the experiment pad embedded in the road, and through the pad, the electric vehicles move and get the transfer the power from the transmission pad to the receiving pad. Receiving pad is in the vehicles. Okay. Then the coil detection system for dynamic wireless charging. So Devendra Patel and his friends put the journal paper using dynamic wireless charging. So dynamic wireless power charging of electric vehicle, the proposed detection system for 5 volt 1 watt system, but they are using high frequency for 460 kilohertz they are using with low cost implementation. Here, the transmitter side and the receiver side, two sides are there. So in the transmitter side, the modulator gives signals to the IGBT based converters. So IGBT based converters in the primary circuit, and in the secondary circuit, diode based rectifier circuits available for converting the received power from the primary side, that is transmitter side, and use energy to the rectifiers, and the rectifier output is less. So we need to boost or increase the voltage. For that, we are using the step-up chopper circuit, and the output of step-up chopper circuit is charging the battery. Okay. Then this another some more projects. This in this project they use the zero voltage switching, ZVS switching for their converters, so that appropriate exact switching happens and low loss, since during the zero crossing it turned on the switches, so loss will be less, and so that is advantage. Then solar powered system only this one, and zero voltage switching for inverter also we are using. Then capacitor bank in the primary as well as in the secondary coils use, lead coils used, and resonant condition they use the resonant condition, so XL equal to XC, purely resistive circuit. And secondary side, diode bridge rectifiers they are using, and battery bank gets the power from the diode rectifiers. And here DC power source output given to oscillator. Oscillator output power is given to the transmitter coil for transmitting the power to the receiver coil, and receiver coil converts that AC to DC with the help of rectifier, and voltage regulator ICs are used for low power devices. So transmitter section separate and receiver section separate, like this we can design and transmit the power. This is for mobile charging. Then high frequency wireless power system, for this one they are using different alignments, whether properly aligned or no alignment, no misalignment or misalignment. So if we are doing like this, how the power is transferred from primary to secondary, that kind of testing done in this experiment. This is the same one only, wireless power transmitter and receiver system with the experimental setup, primary and secondary printed circuit boards of the wireless power transfer system. And this is continuation of the same. So they developed a 500-watt lab prototype, and the air gap is 15 centimeter air gap, and they can achieve more than 90 percentage efficiency. Okay, 120 volt input condition. This is another project. This one 3.3 kilowatt wireless inductive power transfer system with 95 percentage efficiency. The air gap is 10 centimeter air gap. And this is same one, inverter and rectifier arguments. It MOSFET primary side switching, that is power and switches used like MOSFET. But in the secondary side, uncontrolled device diode. MOSFET is uncontrolled device. We can control the operation of MOSFET, but diode is uncontrolled device. So diode rectifier is in the secondary side. Research idea, you can do analytical methods, numerical methods, and experimental setup also. In future, you can use this one for your research. MATLAB example. So I developed this MATLAB. So primary side of transfer around voltage and current values. So the voltage is around 400 volt peak value and current 200 amperes. So, and secondary side of transformer voltage and current, uh, voltage around 100 volts and current around 25 amperes we are getting in this secondary side for this primary side. So primary side we are transmitting 400 volt and current around 200 amps. Then in the secondary side, receiving side, we are getting 100 volt and 25 amperes. And power, active power and reactive power from primary and secondary side with the help of the available voltage and current values. Output voltage around 100 voltage. Okay, so here in this circuit we have the primary side and secondary side. Primary side we are using the IGBT switches for converting the power, and from secondary side we are using the diode bridge rectifiers. So we are calculating the active power and reactive power with the help of voltage current using the MATLAB simulating environments. Okay, so these are some references I have made. So thank you very much for your patience and interest on electric vehicles. So if you are moving to the electric vehicles, we can save energy, and we can save our world by without polluting the environment. Okay. Thank you so much. See you.
Okay, thank you, Mr. Kasi, for your presentation. We have two questions that we would like you to answer. The first question is, what is the difference between electrical vehicles and the hybrid electrical vehicle?
Yeah, yeah. Electric vehicles actually battery operated vehicles, we can say. Then we can have the charging ports. So with the help of the charging ports, we can charge the batteries. But in case of hybrid electric vehicles, we have the gasoline engines as well as the batteries. So the batteries get the power from the gasoline engine power, not from charging ports. So that is the main difference.
Okay, for the second question, it says, how effective wireless charging to charge the electrical vehicles?
How effective?
Yeah, like how effective wireless charging is for electrical vehicles.
You mean effective?
Yeah, someone is asking like how effective is wireless charging when it comes to electrical vehicles? Is it very effective or it's not effective?
Yeah, it is effective. Actually, based on the power range. In our houses also we can charge the batteries, but it takes long time. Okay, but if you have increased power level, for example 22 kilowatt, then we can reduce the timing to around 1 or 2 hours. Within 1 to 2 hours we can charge our batteries. If you still further increase the power level to 250 kilowatt, then within half an hour we can charge the electric vehicles.
Okay. Thank you a lot, Mr. Kasi, for your presentation and sharing this valuable information with us today.
Thank you.